So in order to calculate the formal charge of the atoms, okay, we have this following equation. The formal charge is equal to the number of valence electrons minus the bonded and non-bonded electrons. So we can talk about that in the terms with respect to what we just covered with hydrogen sulfate, or if it's an aqueous solution, sulfuric acid. So we know how many valence electrons from the element. You should be able to tell at this point it's the group number. Okay. You need to consider the elements that are different. So notice that we have the sulfur and the hydrogen, but we also represent the two different types of oxygens. We have the oxygen bonded between the sulfur and hydrogen, and the single oxygen. Okay? So they have two different types of bonds associated with them, so they need to be taken into account. We do not need to take into account 4 different oxygens, because this oxygen is the same as this oxygen. This oxygen is the same as this oxygen. Okay. So if we look through, we have the valence electrons, how many bonds are surrounding it, how many non-bonds or lone pairs. Okay. So if we look at sulfur, the valence electrons do not change, so you should still have 6. Okay. You should still have 1 for hydrogen and 6 from oxygen. Okay. Bonds, sulfur has, in this case, 4 bonds. Hydrogen has 1 bond. Okay. The single oxygen has 1 bond, and the oxygen here has 2 bonds. So 4. And so no non-bonding. Okay. Hydrogen has no non-bonding. So 1 minus, so we have a 0 here. Oxygen, which one? The single oxygen has, again, 1 bond and 2, 4, 6 electrons around here. And this oxygen has 2 bonds and then also 4 electrons. So we follow this rule. Okay. For the same the same rules are going to apply for this structure. Okay. The valence electrons don't change. In this case, we don't have a single bonded oxygen. Both of those have 2 bonds. Okay. It doesn't matter this is a double bond and this is 2 single bonds. Oxygen is still bonded twice. Okay. Sulfur, in this case, is bonded 6 times. Still doesn't have any non-bonding. Hydrogen's the same. This oxygen has nothing because we don't have a single oxygen. Okay. Both of these oxygens have 2 types of bonds, so 2 bonds, and 2 lone pairs, so 4 non-bonding. Okay. So if we look at the charges, okay, the formal charge on individual atoms, the valence electrons minus the bonded plus the non-bonded. And what this bonded means, you might also see this as 1/2 the number of bonded electrons, or how many bonds there are around it. Same thing. So we have valence electrons of 6. Okay, we have 4 bonds, no non-bonding, so 4 minus 6 is 2. So the sulfur is said to have a formal charge of +2. This hydrogen has 1 bond, no lone pairs, no non-bonded electrons, so you have 1 minus 1 equals 0. The single oxygen still has a valence electrons of 6, okay, has 1 bond and 2, 4, 6 electrons around it. Okay, so you have 6 minus 7, which is a -1. So we say that this oxygen has a formal charge of -1. Okay. The double bonded oxygen still has the same number of valence electrons, but this case has 2 bonds and 4 electrons that are non-bonded. So 6 minus 6 is 0. So we represent these formal charges. You can see them as a charge and a circle around them. Okay. Notice how plus 2 minus 1 is 0. So the total charge of this structure is 0. That's fine. So it obeyed the rule where the formal charges, the sum of the formal charges has to equal the sum of the structure. We can do the same thing with structure 2. You can see here. And then we can look at the formal charges for the sulfur, hydrogen, and oxygen. Notice how they're different. So the charges, the formal charges here for sulfur is a plus 2. Here is 0. Hydrogen stayed the same, but oxygen now has a formal charge of 0. So when you look and try to compare two different structures, okay, you need to go and look at the individual formal charges. And the structure that creates so the bonds and the structures that create the lowest amount of formal charges is more stable. So you can see that here we have a formal charge of -1, formal charge of +2. Here everything is 0, which means it's more stable. Now you might run into examples where there are both of them are negative. Okay, both structures give a positive and negative valent or formal charge, and it's by the lowest number. Okay, and also pay attention to the assignment. So sometimes what happens, and we might get through this example today, but sometimes when you calculate the formal charge, and if you create the wrong structure, you'll see something weird like oxygen would have a positive charge. And we know by now, based on the rules, that oxygen should not have a positive charge. It should be negative. So pay attention to the values and by the charges to make sure that everything makes sense and it's the lowest possible values. So I'll leave you with, for lecture for Wednesday, I'll leave you with the rules, the steps, which we've just covered. Again, all the non-shared, non-bonding electrons are assigned to the atoms, which they are found. Half the bonding electrons are assigned. You can also just count the number of bonds because we are sharing. For each atom, write down the number of valence electrons. Then using the Lewis structure, add up the valence electrons that belong to that compound. Subtract the total. And the sum of the formal charges and structures must equal the charge on the particle. Okay. So we'll conclude Wednesday's lecture.